So what we've done so far is we've created models where there was a definite relationship between the x and the y values. There was a definite linear relationship. Now what we're going to do is we're going to try to create a model where there's a little bit of a question mark. So when you do a scatter plot is where you just graph all of the x and y values for a bunch of ordered pairs. Sometimes we see that there's some sort of correlation between the points, that in general, as x increases, y also increases. So I've got a positive-ish line. Notice that all these points don't make a straight line exactly. They just, in general, go up as we go from left to right. Here, they, in general, go down as we go from left to right. Here, there is a relationship, but it's not linear. So this would be like a quadratic relationship that we'll study later on. This would be more of a cubic relationship that, again, we'll study later on, but definitely we wouldn't use a linear model for that. And then this, also something we'll study later on, would not be a linear relationship because there's too much of a curve to it. So what we're looking for is, can we write a linear model using the points? So what we do for that is we're going to write our best fit line. You might hear this called a best fit line. You might hear it called a trend line. You might hear it be called a line of linear regression. Any of those things all mean the exact same thing. So what we're going to do in this video is I'm going to show you by hand how to do it, which is, of course, if you're doing it for a discussion board or a case study, you will do it by hand. So make sure you know how to do it in that way. And then I will also show you how to use in Excel and Desmos.com. So for the first, here is our data set. And so what I'm going to do with this data set is I'm going to first create a scatter plot, because I do need a scatter plot in order to even do it by hand. I need to see the scatter plot. And I'm kind of lazy and I don't want to do the scatter plot by myself. Because in general, it probably is not going to turn out very nicely. So what I'm going to do is I'm going to copy and paste this data into Excel. Now that I have my data in Excel, you can see here on the left, I'll move that over a little bit. Now that it's in there, I'm going to use it to create a scatter plot. So I'm going to highlight only the x and y values. So on some of the tables, there is a value to the left of this that has number 1, 2, 3, etc., or anything else. I would not highlight that ever. I'm going to highlight, all, including the labels, so all of that data I'm highlighting. Now I'm using a Mac, but it's the same process for a Windows. It might just be a different way to get to that menu. I'm going to insert, and I'm going to choose the scatter plot. So notice I have some options here. I want just the scatter plot, just a regular scatter plot. Now, as you can see, I do have a scatter plot, but I've got a lot of open space here, and that's going to make it hard to basically to make an equation. So if I want to change up my x's, I'm going to say go from a minimum of 12 up to 25. Maybe even 14. So I'm just trying to get it so I can see it all on the page and I can see what the trend is. It looks like my first y value starts after 60. So then I'm going to double click on the 60 or on the y value and make the minimum 60. So now I can see a little bit more of what I think that data looks like. And looking at it, it does appear to go up from left to right. So if I'm doing this by hand, I'm going to go to Insert and then Shape. And I'm going to choose a line. And I'm going to draw that line wherever I think it should go. And I'm looking just for the general direction of data. So this one looks good to me. So if I were doing this for, say, a discussion board or a case study, from this point I would take a screenshot. So I'm going to take a screenshot and I'm going to select this. Now on my Mac, that is Command-Shift-4 and then select my area. On a Windows, you would go to your snipping tool and snip that area. So now that I have that, then again, I've just sort of gone through these steps. I've inserted my shape. I'm going to use 2 points to do my best fit line. So now here's the line that I drew and the data that I have. And you can see that my line happens to go through right here, which is the point 14.7, 69.7. And it will go through, I believe I chose this one, which is 17.1, 80.6. So I'm looking for 2 points that occurred on my line. Notice I didn't just choose any 2 points from my data set because I have to use points that went through the line that I drew. So now I'm just going to go through my normal process. I'm going to find the slope. So y2 minus y1 over x2 minus x1. Get your calculator out for the calculations. My first simplification, I get 10.9 over 2.4. Then in a case like this, so in a normal nice equation, we're going to end up with a nice slope that I'll either leave as a fraction if it's not perfect. In this case, I'm really going to just use a decimal, so I'm going to divide these two. I'm not even going to try to turn them into a fraction. I'm going to divide. I'm going to go to the nearest thousandth because we never want to round too closely or too short. So 10.9 divided by 2.4. And so I'm going to round that to about 4.542. So that's the slope I'm going to use. It's okay to have a slope like that when you're using a linear regression model. It will be a decimal. So now I have I have y minus my y value. So choose a point. It doesn't matter which. I'm going to choose my first. So y minus 69.7 equals my slope, and then x minus 14.7. I'm going to distribute, which gives me 4.542x minus 66.767, again rounded to the nearest thousandth. I'm going to add the 69 over, which gives me positive 2.9326, so at this point I'm just going to round to 2.933. This is the equation that I have for this line. So that was my guess at what the best fit line would be. Now, I'm a person, and people, are not as good at calculating things as machines. So what we're going to do next is we're going to look at the best fit line, or the linear regression line that has the least amount of residuals. We're not going to talk a lot about residuals, but just to give you a basic idea, what a computer does when it finds the line of best fit is to find the line that has the least amount of space cumulatively between the points and the line. So it calculates all of that, and for us, it would take a really, really long time to calculate that. For a computer, it happens in a split second. So keep in mind what our equation is, and then we're going to see what the real equation is. So now I'm going to go back to Excel, and I'm going to get rid of that line that I drew in, because I want to do step 7, which I skipped before. I want to find the actual linear regression line. So on mine, I'm going to click on that chart. I'm going to go to, so I'm going to double click on that chart. I'm going to go to add chart element, and I'm going to add a trend line. Again, you will be able to do that. It might look differently than mine. Now, I'm only looking for a linear trend line, so I'm going to click on trend line. So that's the real line. What I want from that line is I want to know what the equation is. So I'm going to click on display equation on chart, which might be a different pop-up window for you to do that. But notice that the real equation is 3.2911x plus 25.232. So looking at what my equation was, I didn't do an awesome job, because my slope was 4.524, which was steeper, and my intercept was 2.933, and this is way different. So I did not do a great job. This is the real one. So again, this is just a screenshot of that one that I just showed you. So here's the real equation, and then the real line that Excel drew for us. So Excel is great, and we use it a lot in mathematics. I also want to show you how to do this on Desmos because it's very user-friendly. So using Desmos, and I'll show you how to do this, I'm going to copy and paste the X and Y table from Excel into Desmos. Again, just as before, if I had 3 columns, I would just do the 2 columns that were the X's and the Y's. Then I'm going to adjust it so that I can see it on the window. And then I'm going to type in this equation, which will make sense once I do that, and that's going to give me the slope and the y-intercept. So let's try that. I'm going to come into Excel, I'm going to copy my data. In Desmos.com, which is the graphing calculator part, I'm just going to Control V, which pasted it, and notice I've got all of my data up here. Desmos has zoomed in to fit my data, and they've also shown me both my X and my Y axis, which is great. I'm going to actually just zoom in a little bit more so I can see. It's not a bad idea to keep it out to where you can see the X and the Y axis. So it's really up to you where you want to zoom that. Then what I'm going to do is I'm going to go to the next line down. So here was my table, and notice that by clicking on that, that gave me all of my points. Here, I'm going to put y equals mx plus b, but I'm going to use y1 so it knows to pull data from this table, and I'm going to use x1 so it knows to pull data from this table. So y1, notice the 1 automatically went as a subscript, and then I'm going to use, mine is above my tab key, that little squiggle line, and that's going to tell Desmos that I want it to calculate the regression line. And then m for slope, and then x1, and then plus b. So there's my y equals mx plus b. Notice it's now created my trend line for me. And down here, we won't talk about the residuals or the r squared or r value. We'll talk about that in statistics if you take a statistics course. But it does give me my m of 3.2911 and b of 25.232. If you'll remember, that is the exact same equation that Excel came up with when we did this in Excel. So notice, same idea. This one I've zoomed in a little bit more, but it's got my m value and my b value, and those two equations were the same. Now that we have a linear model, such as this one, we can use it to answer some questions and to make some predictions. So before, when it was just a lot of points on a graph, we couldn't do any of that. Now we can talk about the data in a more defined way. So let's first look at this slope, which is 3.2911. And we know that slope is the change in y over the change in x. And in this particular question, the change in y was the change in temperature, and the change in x was the number of chirps per minute. So it was cricket chirps per minute based on temperature. When we interpret a slope, we always say for every additional x, there's an additional whatever in y. I'm going to say the cricket chirps 1 additional time per minute for every increase in temperature of about 3.2911 degrees Fahrenheit. So that is increasing, y is increasing temperature as x is 1, because I would write that over 1. So the cricket chirps 1 additional time per minute for every increase in temperature of about 3.291 degrees. Interpreting the y-intercept in the context of our question, basically a y-intercept is the point 0, b. So 0, 25.232. To interpret that, I would say when x is 0, y is 25.232. So when the cricket is chirping 0 times per minute, the temperature, y, is about 25.232 degrees. Now, sadly, that probably means that the cricket is dead. But let's just, sunny disposition and pretend that it's sleeping for a long time. So, last one, estimate the temperature when a cricket chirps 18 times per minute. So 18 times per minute would be Am I going to plug that in for X, or am I going to plug that in for Y? So we're estimating the temperature, and we know the temperature was Y. So I'm going to plug that in for X. And so in solving that equation, I find 84.47, we'll call it. So it says estimate the temperature. Remember, that's Y, when the cricket chirps 18 times per minute. So I would estimate the temperature at about 84.47 degrees Fahrenheit. I'll let you do this one whichever method you prefer, so using Desmos or Excel or whatever. Go ahead and find the actual least squares regression line. So don't do this one by hand, do this one for real, using one of those two, and then press play to check your work. So if I'm using Desmos, I have already plugged in my values. I'm going to use y1 and then mx1 plus b. And again, notice that it's done all of the work for me, which is great. So now I can look at my equation and know that my slope is of course negative because it's decreasing as we go from left to right, and that my b value is 98.145, which means that here it's crossing at 98.145, which they've rounded to 98.15. So using my data from Desmos, my least squares regression line, I've used the slope that they provided me with and the y-intercept they provided me with. That's my least squares regression line. That's the equation. Now I'm going to use that model, so using this, to approximate the average for a student who misses 6 classes. So my X here is number of absences from class, and the Y is the class average. So they're asking me to find the average, so I'm finding Y when X is 6. So notice there's no 6 on here, and even if there was, I couldn't use it because I have to use my model. So I'm going to rewrite my model, and you're either replacing X or replacing Y. In this case, we're replacing X, and then we're going to use our calculator to find the answer. And in using my calculator, I found 78.5214. My sentence would say a student who missed an average of 6 classes would have a class average of about 78.5%.